Okay, so for the first one, 7 square feet into square inches. Put 7 square feet over 1. Square feet will go on bottom, square inches on top. What's the equivalency between square feet and square inches? 1 square foot is 144 square inches. So 7 times 144, 1,008 square inches. Anybody have that? 369 square feet into square yards. What's the equivalence between square feet and square yards? I'll give you the hint. The larger unit is always 1. So which one's larger, a yard or a foot? Yard. So square yard's bigger, so that's 1. 1 square yard is how many square feet? 9. So yes, that is 41. Because since that's on bottom, it's telling us we're dividing. So 2.7 square centimeters into square millimeters. Now this is where we can use our chart. To get from centimeters to millimeters, how many spots is that on the chart? It's actually just 1 spot to the right. But since it's squared, we double it. So it's 2 spots. 270 square millimeters. 1,900 square centimeters into square meters. To get from centimeters to meters, how many spots is it on the chart? 2 to the left. Since it's squared, we double it, so it's 4. So 1, 2, 3, 4. That is 0.19 square meters. Anybody have the first 4 all right? Any questions on the first 4? Next, we have 5,184 inches squared. That over 1. Inches squared has to go on bottom, so they cancel out. We're going into feet squared. 1 square foot is 144 square inches. We divide, we get 36. And finally, 0.83 meters squared into millimeters squared. You get from meters to millimeters. It is 3 spots to the right on the chart, so the decimal point has to go 6. Have to add zeros. 830,000 millimeters squared. So let's say we have a piece of land. There you go.
You don't have to use, I mean, 0.4.
0.4, what do you mean?
No, I mean, 3.10
Yeah, I have to move the decimal point over. It goes 3 spots to the right on the chart, so I got to double it, so I go 6 spots to the right.
Yeah.
So I go 1, 2, and then I got to add zeros to go the rest of the 6. So let's say that we have a piece of land here that is 150 feet by 320 feet. In your notes, figure out how many acres that is for me quick. What'd you come up with here?
1.1.
Okay, let's check it out. Area is going to be 150 feet times 320 feet, which gives us how much? 48,000 square feet. 48,000 square feet. How am I going to convert that into acres? Obviously, square feet go on bottom. What's going to go on top? What are we converting it to? Acres. Which one's going to be the 1? Acre is. Acre's the larger one, so that's going to be 1. And how many square feet are in an acre? 43,560. So this tells us that our square feet cancel out. And we're going to divide 48,000 by 43,560. 1.102, 1.1 if you left it at that. Not so bad? 1 acre is 43,560 square feet. What's that? 1 acre. Yeah. Let's check out this one. Try that one for me in your notes. Okay, so we'll start out with the 5,184 square inches. And I did this one on purpose because we haven't talked about a conversion from square inches into square yards. We could either find the conversion from square inches into square yards, or we could go from square inches to square feet and then square feet to square yards. Doesn't matter. If I put square feet here, 1 square foot is 144 square inches. Square inches would cancel out. And then the next step, I'd want to get rid of the square feet and go to square yards. What's going to go in here for numbers? Where's the 1 go? The square yards or square feet? Square yards. 1 square yard is how many square feet? 9. So the square feet cancel out. Now I do have square yards. So on top, I've got the 5184 times 1 times 1. What am I going to do with the 144 and the 9? Divide by each other. So 5184 divided by 144, then divide by 9. I get 4. So it's 4 square yards.
I remember you in trouble like that on your calculator? Dividing it like that?
Not like that. Not on these. They won't. No. I mean, if you really wanted to be safe, you could multiply out the top. Say 5184 times 1 times 1 is 5184. 144 times 9 is 1296. Then divide them out to get 4. So if you do it like this, no, because your calculator will always do left to right when it's all division. But if you wanted to be safe, the safest way to do it, and that was a good question, is to multiply the whole top and get 5184, then multiply the whole bottom and get 1296, and then divide them out. Is the safest way to do it. I just took a little shortcut with my calculator because I knew it would work out the same.
Could you just enter the 5184 and then you divide that because it's all ones, and then divide that by 1.4, then divide that by 9.
Yeah, that's what I did.
Okay, yeah.
Yeah.
The 4, you divide it by 9. Then it's 144. Well, it's up to you.
Yeah, no. So anyway, we can do those conversions. And yes, there's a lot of different ways we can calculate this out and make it work. As long as we're aware of our order of operations as we do it. But you're right. This is probably the safest way to do it, is to do all the numerators and all the denominators and then divide it out. So we left off yesterday. We were talking about areas, calculating areas with stuff. And we had found the area of a circle. And we said the area of a circle was pi times the radius squared. We have previously discussed the circumference of a circle. How do we find the circumference of the circle? Pi times diameter, right? Or since the diameter is 2 times the radius, 2 times pi times the radius, right? 2 times the radius is just the diameter. So if I have a circle with radius r, the circumference of that circle all the way around is 2 times pi times r. If I cut that circle in half, what is the distance around half of the circle? How would I find that? Well, I would take the full circumference and I would do what to it? Divide it by 2. What happens when I divide that by 2? It's just pi times r. So this distance around half this circle is just pi times r. The reason why I'm doing that is I'm going to now take that half circle and I'll cut it into really thin pie slices. As thin as I can cut it. I'm going to fan out those pie slices. So it looks kind of like the teeth of a comb. Like that. Then I'm going to take the other half circle and I'm going to cut it into equally thin pie slices. And I'm going to fan those out and I'm going to slide them in to the other ones. What I have right now, if I cut those slices thin enough, this basically turns into a rectangle. What's this distance right here? R. It's my radius, right? What's this distance right here? Pi times r. If that were a rectangle, its area would be its length times its width. Pi r times r is pi r squared. That's where the formula for the area of a circle comes from. What we just did here is the basic principle of calculus. You cut stuff into thin enough slices and you can turn it into rectangles. Now, we're not going to do any calculus in here, but it's the basic principle. I mean, from here on out, we better not. What you going to do about it? Cry a little bit? Run away screaming? Kick the door on your way out? You can't even slam these doors because that automatic closer is set so tight.
I can try it.
Good try. Okay, so what we're going to be looking at now is how do we do some more complex calculations on these areas. For example, we might have a shape like this. Assume that all those corners are square corners or right angles. We'll say that that's 32 inches. That's 21 inches. This over here is 15 inches, and this is 12 inches. Be consistent with my notation. First thing I need to do is find my missing lengths. What's this length going to be? 6 inches. Okay. Anybody have questions on how I got that 6 inches? Okay. How about this one? 20. Good. Any questions on where the 20 came from? Now, as we've mentioned a little bit before, we got 2 different ways we can go about this area here. What's one way we could do it? Break it up. Cut it across here or down here. Which way do you want me to go? Across or down? Across. Okay, we'll cut it across here. So we've got 2 shapes. Piece 1 is how do we find its area? It is 15 by 32. Otherwise known as 480 square inches. Piece 2, how do we find its area? 12 times 6. Otherwise known as 72 square inches. So the area of that, we add those up, we get 552 square inches. What's another way we could have done that? Yeah, we could have made it a complete rectangle and subtracted out. So that big rectangle would have been 32 inches by 21, which would be what, 672 square inches. And then we could have subtracted out 6 inches by 20 inches, which is 120 square inches, which gets us to 552. We get to the same result. Now there are some problems, like this problem here is the same amount of work to go either way. But there are some problems where we have to go one way or another. Let me show you what I mean. How would you find the area of this figure? Well, I'm going to have to divide it up first. This is what I'm going to actually cut it into a rectangle and a half circle. So I've got two pieces. Piece 1 is 8 inches by 20 inches. 8 by 20 is 160 square inches. How am I going to find the area of piece 2? Well, I'm going to imagine that it's a full circle, right? The area of that full circle would be pi times, what's its radius? 4. How'd you get 4? Yeah, if it's 8 across here, that means it's 8 across here. So it makes the diameter of that circle 8. Radius is half the diameter. So the radius is 4. So pi times 4 squared. But what do we have to do with that? Divide it by 2 because it's only half a circle. Gives us what? 25.12 inches squared. We add those together, we get 185.12 inches squared. That's our area. That one, there was really no way that we could have made it bigger and subtracted out missing pieces. Wouldn't have worked for us that way. On the other hand, this one here, can I cut this into smaller pieces and add them up? Say no. No. The only way I can do this is to make it a complete rectangle and then subtract out the half circle. So that rectangle is 16 inches by 12 inches, which is 192 inches squared. That half circle is pi times what's its radius? 8 inches. Good. If it's 16 across here, it is 16 across here. Makes the diameter 16, so the radius is 8. So pi times 8 squared divided by 2 is what? 100. What, 100.48? Is that right? That's what I'm getting.
How much per pi?
Pi is always 3.14. 100.53. You use the pi key. Yeah, I use 3.14. Same difference. So we subtract there, we get 91.52, or if we use yours, you get 91.47. Pi is always 3.14. So here was one where we had to find a larger area and subtract out the missing piece. So let me try something here. To you. So let's say that piece there is 2 inches. This radius here is 8 inches. Center to center of these circles is going to be 8 inches. That make that piece 8 inches. Never mind. Come mark that one. From there to there, make that 32 inches. From there to there, well, let me figure that one out in a second. From here to here is 8 inches. Oh, I gotta make sure this works out now. Actually, the rest of those dimensions you should be able to figure out on your own. Actually, the rest of those dimensions you can figure out on your own. So in your notes, find the area of that. I'll give you a little hint. Cut it like that. Okay, so I gave you this little hint for dividing it up. I'm going to look at this first rectangle here, which is going to be 16 in this direction. We need to figure out how long it is in this direction. Well, how big is this piece going to be? If this is 16 and this is 8, this piece has to be 8. Which makes this 8, because it's both of the radius of the same circle. 2 radii on the same circle have to be the same size. So those are 8 inches. If this is 2 inches here, what's this have to be here? If that's 8, this has to be 6, which means this has to be 6. So we've got 6, 8, and this one's already given as 8. So that adds up to 22. This has to be 10. Obviously not drawing the scale. So now that we have those distances, figure 1 there is 16 inches by 10 inches. Or 160 square inches. Figure 2 here is 8 by 16. Which is 128 inches squared. But notice I'm not writing it over here yet. I'm putting it back here because I have to subtract out this quarter circle. That circle is pi times 8 squared because it has a radius of 8. But then I'm going to do what to it? Divide by 4 because it's a fourth of a circle, which ends up being 50.24. So I subtract that from my 128, gives me 77.76 inches squared. So I have those two pieces so far. So that's this piece and this piece. This next one here, piece 3, is pretty simple. That is 8 by 8. 64 inches squared. Piece 4 will be this little one here, we'll call it. That's 6 by 2. Inches squared. We'll call this piece 5, this quarter circle. How am I going to find that? Well, pi times 6 squared is my radius, divided by 4. .26 inches squared. And finally, we'll call this piece 6 here that half circle. So it's pi times 8 squared. Why am I only dividing by 2 instead of by 4? It's a half circle, not a quarter. The other ones were quarter circles. It's a half circle. So pi times 8 squared is 100.48 square inches. And now it's just a matter of adding those up, which will give us what? Is that 442.50 square inches? Sound right? Pretty close. That's that precision we like to see, huh? I'm pretty sure that's right. 442. Surface area is defined to be the area of all the surfaces added together. So for a cylinder, we have 3 surfaces. We have the circle on top, the circle on bottom, and then we have that what wraps around the sides between the 2 circles. Top is called a base. Bottom is called a base. Now we think of a base as being the bottom of something or what it sits on. A base is also what it's based off of. This shape is based off a circle because the circle is the one shape that goes completely through the object. If I were to slice it, it would be, the spot I would slice would be shaped like a circle. So the area of the circle for the base is pi times, where am I getting the 4 from? Yeah, the diameter is 8. Half of that is 4, my radius. So that'd be 50.24. Why am I writing that down twice? There's the bottom and there's the top. Now I have what's called lateral area. And that's that surface that connects the two circles. What that really is, if you think about it, here's a cylinder, right? If I slice that cylinder down the side, I can roll out that surface and I have a rectangle. The height of this rectangle is just the height of my cylinder. What's the length of my rectangle here? Yeah, the circumference of that circle that was the base of my cylinder. So the circumference of my base, the perimeter of my base, in other words, is pi times 8, which is 25.12 inches. So my lateral area is at 25.12 inches times my height of 10, which is 251.2 inches squared. I add those up, I get 351.68 inches squared is my surface area of that cylinder. Try that again. Pretend that looks like a washer. If this washer is 32 millimeters diameter, this is 6 millimeters. Find the area of the metal. How would we find that area? Well, I have two circles here. Just like we could find, we did these, we found the bigger rectangle and subtracted out the missing pieces. Same here. I can find the big circle. What's its radius going to be? 16. Half the diameter is 32. Radius will be half that, 16. So pi times 16 squared is going to be what? $803.84 works for me. That's millimeters squared. And then I can subtract out the smaller circle. What's the radius of that smaller circle going to be? Well, if it's 16 all the way out to here, this is 6. I subtract, this has to be 10 millimeters. So that area is pi times 10 squared, or 314.16 millimeters squared. If we're using 3.14, it's just 314, of course. We subtract to get 489.68 millimeters squared. Is that area? What do you think? Good stuff? Okay. In your big book, page 269, I think I gave you this one yesterday, but I wasn't sure. Exercise 9.5 and 270. Exercise 9.7, that's on the metric areas yet. Also in the big book, page 592 through 594. This should be exercise 27-2. Do the odds there. In the packet I gave you that had that unit 19 on it, was unit 24 and 25 in that packet? Okay. Went from 19 to 29? Okay. I didn't think that was it. So it's just these pages out of the big book is what you have for tomorrow. And I did get long-winded today, and I took up your whole hour, so you don't have any time to do homework, so you have to do it at home.